So, like I said, you're not going to have to graph these by hand. There'll be multiple choice. But you still want to like identify what's going on. It's going to make your life easier because it makes all the graphing you're going to do. You can identify H's, and K's and recognize them when you see them and how the graph changes with respect to them. Graphing becomes a lot less painful. You're not supposed to graph something for the very first time by knowing what you're doing. You plot a bunch of fun. That gets tedious. Punching in a bunch of numbers, plotting individual points becomes tedious. There's always going to be a pattern to it. That's why it's a function. Certain functions will do the same thing. If it's 1 times x or any mx plus b, x to the third, it's always going to be a line. Whenever you have an absolute value, it's always going to be a v shape. Take the square root of something, it's always going to look like the radical sign. X squared, anytime we have just the highest power is a 2, something to the second power, it's always going to be a parabola, always. We just need to know where to put it. Does it go up? Does it go down? How wide does it go? How narrow is it? Those are things we can alter. Okay, x to the third will go like this. Okay, x to the fifth will go like this. X to the seventh will go like this. X to the ninth will go, all the odd functions go like this. Maybe an x to the third might go like this. It depends upon if there's other stuff in between. But you're going to have 1 point down, 1 point up. Maybe it'll be like this instead of that little bit. I wonder if I can get disability because I can't use my arms to do the graphs. But then I'm in that robot contest. Related. Maybe because students aren't awake at 8:30, they're not studying anymore. No, it's paragraph, square root. We know the first point you're going to see is going to be your origin 0, 0. The square root of 1 is going to give you 1, 1. And then, square roots don't like numbers. Square roots like nice numbers. If you're going to plot a number, plug in a good number. So if I was actually going to pick a bunch of numbers to plug into y equals the square root of x, 0 is good. Square root of 0 is a 0. 0 goes in, 0 comes out. 1 is good. The square root of 1, x is 1. I get 1. 1 goes in, 1 comes out. But 2 sucks. Because trying to plot square root of 2 is an irrational number. An irrational number is a number that the decimal value never terminates and it never repeats. It goes on forever like pi, and it never repeats a pattern. You can approximate it. The square root of 2 is approximately 1.414, but it goes on forever and never repeats a pattern, never has the last digit. It's not a perfect square. What times itself is exactly 2? 1. When you think about it, 1 times 1 equals 1. And then the next nice 2 times 2 is equal to 4. So what times itself is 2? There's no nice integer. There's no nice answer. Same thing for 3. What times itself is 3? I wouldn't want to use 3. Y equals square root of 3. That's about 1.732. That's not a nice number. The next nice number to use is 4. Because we have an answer to that. The square root of 4, what's the square root of 4? 2. So when x is a 4, we get a nice value of y. We get 2. The square roots, you actually have to think about what you want to plug in before you plug it in. The other ones you could plug in. If you want to plug in 1, 2, 3, 4, 5, it's not going to hurt. Squaring 1, squaring 2, squaring, we got answers. Absolute value of a 1, 2, 3, negative 1, 2, those are all fine. Square roots can be big. Cube roots. It depends upon what you're plugging it into. But the good news is you're not supposed to plug anything in. You're supposed to know what these graphs look like. So once you get a handle on where you're at, just draw the thing. But if we were plotting it, the square root of 1 is 1. Then we're going to skip plugging in 2. We're not going to plug in 3. We plug in 4 next. When we took the square root of 4, we got a y value of 2. So when 4 went in, we got a 2. What's the next nice perfect square? I'm going to give you a hint. We'll give you a hint. Look what we took the nice perfect squares. Square root of 0, we got 0. Square root of 1, we got 1. We skipped 2 and 3, and then we plugged in square root of 4, we got 2. 0 was the answer. 1 was an answer. 2 was an answer. So the next answer better be what? 0, 1, 2? 0, 1, 2?
3.
3. So 3 is the square root of who? Inside here would be 9. You see how the answers are going one at a time? This answer, when you plug in 0, comes out 0. Then we got an answer that was 1. Then we got an answer, square root of 4, comes out as a 2. So it looks like the answers are going up one at a time. 0, and then 1, and then 2, and then the next one should be 3. So what should I plug in to the square root of x that's going to generate 3? I want to pick the square root of 9 to get a 3. That makes sense. You got to pick them carefully. So the next point, this only goes up to 7. So I'd have to go over here. There's 8, there's 9, and it would be here at 9, 3. The next answer, 0, 1, 2, 3. What would the next answer be? 4. So what would the next x value have to be inside? A 16. Because what's going to make 4 as an answer? I take the square root of 16. So the next point would have to be all the way over here. There's 9, 10, 11, 12, 13, 14, 15, 16. And it would just be up here at 16. 4. So it goes at a very slow, but it's doing that. What you need to know is the shape. The shape looks like the square root of apples. All right. And that's, we know it looks like that. And I'm not going to leave that messy. We'll leave it like this. We're going to square root. That's a 9, 3 just machine. Point of reference, and this was f of x. I'm sorry, it was h of x. Was it negative? I forget. Or was it flipped? H? Yeah. Was there a negative in front of this?
No.
Okay. All right, so everything you need for all your graphing needs, right? The A in front of the function is going to reflect the graph across the x-axis if it's less than 0. If it's greater than 0, it's just going to be your normal paragraph. But if it's less than 0, it's a negative number. Everything above the x-axis flips below, and if you have stuff below, it's going to flip above. It reflects the graph across the x-axis. Inside the parentheses with x is where the horizontal shift would happen. Horizontal shift because it would change the x value before you plug it into the function. That's why it's going to change the positioning left and right horizontally. It's a built-in negative. So if there is something in the parentheses with x, x plus something or x minus something, since that's a built-in negative, when you take out, if you think you see an h, take out the opposite sign of that number. You're going to take out the opposite sign. K happens after the function happens. So it'd be after, in this case, after an absolute value occurred, or after the square root happened, or after the square happened. That's where K lives. K has a plus in front of it, so you're going to keep that sign. And that's the vertical shift. So for the square root, you're trying to identify A, H, and K. What is the A right here? It's a -1. And that means it's going to flip. Instead of going up to the right, it's going to flip upside down. It's going to go down to the right. And I recommend, even though if the test question is going to be multiple choice, make the list. So if you make the list of what you're looking for, now you have a checklist of what to actually look for. Don't try to just kind of go, all right, I'm looking for these things and not write the thing down and hope you see it. If you don't list them, next to the problem, you're not going to actually see them in the graph. What is H in here? 0. And what's the K afterwards? So there's no shift at all. There's no left, right, there's no up and down. So the only thing happening is this is going to get flipped down below. So 0, 0, that first point's not going to change. It was at 1, 1, so that would flip down here to 1, -1. That right here is at 4, +2. So the y value is going to flip down to 4 down here, -2. And that was at 9, +3. So that's going to flip down to 9, -3. And you will not. Big problem with that first part.
So if the negative sign outside the square, then it's kind of still if it was inside, it would be.
If it was inside, that's a different flip. That's a flip across the y-axis. We didn't talk about that for the T. Not going to do that to you on your test at all. But it is in the home. It's in number 19. So we're going to finish up number 19 in here. Not going to finish it up at 10. Just saves time, and the people at 10 o'clock want to see it, they're going to watch the 8:30 news. Okay. In addition to that, I'm not going to do those. The last two parts of number 19 are not going to be done to you guys. To them or to you. To anybody. If my mom was still alive, I might do it to her. She'd make me go get that stick and eat me with something. Therapy. So now, for G, what is A? +1. So +1, so you know it's going to go that way. Just kind of getting these pieces of the function. Everything that the numbers are telling you, visualizing it right below. A is a +1. And not just positive, it's a 1. Which means it's not stretching it. Later on, it stretched. You should have seen the tears coming out of the trick you provided. Things and all sorts of things. But they just have to realize, just recognize what's an A, B, H is a Gates. That's all. Everybody's got a purpose. And then inside, is there an H? What is it? It's a -1, and we have a K. 0, so that square roots, they don't have a vertex, they have a first point. So that first point that you want to plot is at HK, which is -1, 0. This is a horizontal shift to the left 1 unit, right there at negative 1, 0. And it's going to go that way. Everybody's going to shift 1 to the left. Every value is going to shift 1 to the left.
One question. Okay, so for the x plus 1, so a is 1, h, y is h negative 1 if it's not in the parentheses.
Well, parentheses is, it is. A square root is actually an exponent, it's a 1/2 power. So it technically is in parentheses. H is always, if there's an H, it's messing around with your X. Okay, yeah, messing with your X. Because it's the horizontal shift. H is the horizontal shift. So it has to be in the function with the X. And if it's messing with your X, it's not a nice person. It's a negative. It's a negative. So that's that built-in negative, take up the opposite side. So there's no, and first of all, there's no way it can be the K because it's not after the function.
Okay.
It's changing your X value. And you always take out the opposite of what you see. So since we see +1, there has to be a negative 1 to the left. Okay. And then if we think about it one more time, remember, it's just a horizontal shift 1 to the left. If you think it goes 1 to the right, if you did, and if you just went, all right, that's a positive 1, so I'm going to move it here. And we're just going to draw it this way. So if you think it's a positive 1 and you do this, you're saying that plug in 1, we get 0. We'll plug in 1. What's 1 plus 1? 2. Is the square root of 2 equal to 0? No. That's why it's not going to the right when I see +1. It's going to the left. So if I plug in -1, what's -1 plus 1? 0 and square root of 0 is 0. Okay, 1 to the left, opposite side. And if we plug in 1, what used to happen at 1, I'm plugging 0 in. This is going to go to the left 1 unit. So instead of being at 1, it's going to be at 0. So if I plug in 0, what's 0 plus 1? Square root of 1? We're at 1. So that point got shifted here. This point should shift to 3, 2. It's going to go 1 to the left. So 4 is going to shift over here to 3. So I should plug in 3 now. What's 3 plus 1? And square root of 4. So that's going to happen at 3, because I plug in 3 for x, 3 plus 1 is 4, square root of 4, 2. And to make this 9, 3 happen, I can't plug in 9. 9 plus 1 is 10. To make a 9 happen, I have to plug in 8. So the 9 shifted 1 to the left, and we're now at 8, and that's how we get the 3. Everything got shifted 1 to the left. Okay. And then h of x has 2 things happen. What is a? Positive 1, so it's going to go right side up. What about h? Positive 2, and what about k? So the first point, the hk, is at Q1. So it's going to be 2 over and 1 up. So where it used to be here, at 0, 0, we're going to move that point over 2 and up 1. It's going to be here now. Every point's going to go 2 to the right and up 1. So 1, 1. If I add 2, I'm at 3. Up 1, I'm at 2. So this is going to be a 3, 2. the 4-2, I'm going to add 2 and up 1. So this is going to be at 6-3. Okay. 3-2. Plug in 3. What's 3 minus 2? What's the square root of 1? What's 1 plus 1? So when I plug in 3, I get 2. Plug in 6. What's 6 minus 2? 4. What's the square root of 4? What's 2 plus 1? So when I plug in 6, I get 3. Everything has been shifted to the right and 1 up. So the graph is on that one. Take this old number, this 4-2. We're going 2 to the right, so you got to add 2 to the x coordinate. So it's now 6. We're shifting it up 1, so the y value is going up 1. So that's now going to be a 3. 9-3. That old ordered pair. We're going to go 2 to the right, so we're going to add 2 to the x and get 11. We're going to go up 1 because k is 1, so we add 1 to the y value, and that's a 4. So when you plug in 11, you get a 4. H of 11. So that would be the square root of 11 minus 2, and then a plus 1. What's 11 minus 2? So square root of 9 plus 1, what's the square root of 9? So that's 3 plus 1, what is it? 1. So when 11 goes in, we get a 4. The horizontal shift changes the x value. And the vertical shift changes the y value. So that's why I identified what's A, what's there, what's K. That's what it boils down to. What is A, H, B? So that's 15. Number 19. Tuesday. Nineteen and Thursday. So, This is 19 for F and G. So here's part. So we have to take that old picture, that's a picture of y equals f of x. And we want to graph the new picture, y equals f of negative f. This is what I said I'm not going to do. Not going to have you do anything worrying about a negative x. Changing the sign of x on the inside. We're not going to do that. But let's just talk about it. This is what you do know. So let's just say you have y equals g of x, and that picture looks like this. G of x is this. So now you're going to do y equals, and we'll put a negative in front of the g of x. So in other words, we're plugging in, or we're letting a equal a negative 1. Negative 1 times that old picture, times that old. Right, that old function. If a is negative, what does it do to the graph? Reflection across the x. It flips it. It flips it. If you have a negative times a negative, you're going to get a positive. If you have a negative times a positive, it becomes a negative times positive. It's going to be a negative. So a new graph these are negative numbers. So this negative times those old y values, they're now going to be up here. These are positive y values. So a negative times those old y values multiplied by a negative, they'd now be below. Now, at that point, y is 0. A negative times 0 is still 0. Right here, y is 0. Negative times 0 is still 0. These are negative y values. So times a negative, they're going to flip above. And then these are positive, so they're going to flip below. It's a reflection. Again, reflection across the x-axis. Anything that was above is down below. This got flipped up. That got flipped down here. That got flipped up there. That got flipped down here. And so it did this. Okay. Don't care what the graph looks like. That's what it does. So if I put a negative, remember, this is y. This is what y. These are all the y values. And if I put a negative in front of the old y values, the old Y values basically just change sign. So I'm trying to lead you to the answer of my next question. If I put a negative in front of my old Y values, negatives become positive, so they flip over the x-axis. Positives become negative, they flip over the x-axis. So if I put a negative in front of the original x values. So in other words, if I say we're starting with x equals 4, and I say, all right, but I want you to plug it into this. So if I plug 4 into this, what do I get? I get negative 4. But I'm concerned positive 4. But when I plug it in, it becomes negative 4. So what does that do to my original x? It changes its sign. And if it was positive 4 over here, and I try to plug it in, where's it going to go? Over to the other side. It's going to flip it across the y-axis. If a negative in front of the function flips it across the x, then a negative in front of the x is going to flip it left and right across the y, because you're changing the sign of the export. If I change the sign of this -2, put a negative in front of it, it becomes a what? So now it's over here instead. Okay. That's what happens when you put a negative in front of your x. Okay. It changes sides on the y-axis. Think about it. You ever like been with that same person forever, then all of a sudden becomes somebody completely different? You've never seen that negative side of them? It just kind of flips on you. Yeah. Put a negative in front of them, they flip sides. You know who they are anymore. Like some axis is dividing you now. See how it applies light? When am I ever going to use it? No. Can you just put everybody in an absolute value that we know be positive? So, the problem is this. We only know answers for 0, 1, 3, and 4. If we plug in 0, we got an answer. Plug in 1, we got an answer. Plug in 3, we got an answer. Plug in 4, we got an answer. If I have f of -3, I don't have an answer for f of -3. I don't. I don't have an answer for, these values over here are values for y equals f of just x. So I don't have an answer for f of -3. They didn't give it to me. And you don't have to have it. All we're going to do is look. So what you have to do, since you see that there's something in front of x, your new x is going to change. Your new x is going to change. How is it going to change? It's -1 times the old x. That's going to go here. So -1 times 0 is what? 0. I'm going to plug 0 into here. Let's see what we get. F of -0 is just f of 0. And when we plug in 0, what do we get? -1. Okay. Which makes sense. Because if it's supposed to reflect across the y-axis and you're on the y-axis, if I'm on this line and I'm supposed to go from one left side to the right or right to the left, and I'm on the line, how can I go left to right, but if I'm on the line, I can't, I'm not moving. I guess if I'm facing this way, I can face this way, but I'm still on the line, I can't flip. I'm saying flip. I wish they would have started with something else, but they didn't. And here, the old X is 1. So before I put it in here, it's going to be the opposite of that old X. So it's going to be -1 times this 1. So it's this one. -1. So now watch how it works. I can't plug -1 into this function. I cannot do this. Y equals f of -1. Because there is no point, there is no y value for that. From the direct function. But over here, if this is my function, y is going to equal f of, there's a negative, and then I plug in this x, which is -1. So what am I actually going to be taking? Y equals what? F of who? What's a negative times a negative? So it actually becomes +1, which is 0. So when I plug in -1, I get 0 because that point got flipped over to here. It flipped over the y-axis to the other side. It went from this x value of 1, 0, over to this side, -1, 0. A reflection to the other side. The x value is changing. How is the x value changing? You're going to use the opposite of what this is, the opposite of the old x. So since this is +3, we're going to take negative of that +3. We're going to use -3 here for my new graph. Y equals, plug it in, f of negative, and I'm using -3. So I'm actually going to be taking f of +3, and when you plug in +3, you get 1. Which is what you should get. Because this over here is just going to reflect over to the right side, or sorry, over to the left side. So if this is 3, 1, then flip it over, this should be at -3, 1. Three, 1 on this side, it's going to reflect over here to -3, 1. So what will this set be? If this is 4, then it's going to flip over, it's going to become what? -4, what will the y be? The y is not changing. They take that straight edge, and dots. Horrible, but I didn't use it. So we're good to scale. We're just mapping all of these points and reflecting this 4, 2 to -4, 2. This 3, 1 gets flipped over here to -3, 1. This 1, 0 flipped over here to -1, 0, and that didn't move at all. Okay. One other thing to point out. Look at the connection of what we did here. You're supposed to graph y equals f of -x. So when you compare what you had to start with And what that graph represents, this is just y equals f of x. So now you want this. Is anything, what is A? What is A right there? Positive 1. Is there an H?
No.
H is 0. Is there a K? So there's no horizontal shift. There's no vertical shift. There's no flipping across the x-axis. So the only thing changing is the sign. All you're going to do is change the sign of x from here. All of these x's will be opposite sign of these old x's. It's the opposite of these old x's. Negative of those x's. Opposite of 0, 0. Opposite of positive 1. Now it's going to be negative 1. Change the sign. Opposite of positive becomes negative. Opposite of positive becomes negative. If you had a negative 12 over here, what would you have here? Positive 12. Change the sign. That would be your x coordinate there. That's what you're going to plug in for your intermediate set of order pairs. And then since you're not multiplying, you're not flipping it across the x, you're not multiplying by a number, you're not changing the y value at all. Remember, f of x is your y value. And you're not shifting it up or down. You're not changing the y's at all. Then these y values are not going to be any different. They're going to be exactly the same numbers. And the way you do these graphs is you just use order pairs.
So are we only taking the x values?
Yeah, because the only thing that changed from the old graph to this graph is the x that are now opposite. That's it. What's different? It's kind of like going back to Sesame Street. What is different about this one to this one? One of these things, it doesn't belong here. Can you guess which one? Negative x, so what does it become? These are all opposite signs of the old x's. The y's are the same if you have this as well. So we're changing the sign of x. So these are all opposite of those old, but you're also going to change the sign of the y's. So that would be positive 1 now, 0. That'd be a negative 1. That'd be a negative 2. Okay. G. Okay. Hopefully you had enough coffee, had a decent breakfast. You're gonna need a little brain energy for this. The only answers we have for f of x is when we can plug in 0, a 1, a 3, or 4. Okay? Right now we have a as a 1. So the y's aren't going to flip. Inside h is a 0. So there is no horizontal shift. There's something in front of x though. We'll talk about that in a minute. H is a 0. There's no horizontal shift. K is a 0. There's no vertical shift. We're not going up or down. What's happening is, before I actually plug something into the function, before I actually take f of a number, I have to take 1/2 of the x. I have to divide x by 2, and then I can plug it in. That's what I do. Now, here's where I really wish I wouldn't just start with 0. I only know f of 0 equals -1. That's this. F of 1 is equal to 0. I know that f of 3 is equal to 1. And I know that f of 4 is equal to 2. That's why I got those ordered pairs, and that's what I'm using. I only know what the function is gonna equal if I can plug in a 0, if I can plug in a 1, if I can plug in a 3, or plug in a 4. That's all I know. So if I just try 0, just for kicks right now. And understand that this is not the norm because I wish they would have started with 0. If I use 0 right now, then I plug it in, I get y equals f of 1/2 of x. My x is 0. What's half of 0? 0. So if I let my new graph start with 0 and I plug 0 in for x, I have to take 1/2 of that 0 before I can plug it into my function. Half of 0 is 0. So now I can plug 0 into here, and when I plug 0 in, I get negative. It didn't change. Which is why I wish it would have started with 0, but they did. That's right. Is it always going to be like that? No. Otherwise, 1/2 doesn't do anything and that falls apart. But now, why? Let's just say, oh, it must always work like that. Let's get on that boat. Don't write this down. Okay, I'm ready. I'm going to plug in 1. And you go over here and try to plug in 1. And you go, y equals f of 1/2 times 1. What's half of 1? I get f of 1/2. So now I'm looking up here. When I plug in a half, what is, I don't have an answer. They don't tell me what 1/2 gives. I can't make it up. So I must not be able to use 1 right here. That's what I can't do. I want to have take f of 1 after I take half of something. Half of what number is 1? What is 1/2 of it? 2. So what x do I need to actually start with? It's going to be 1/2 of this x is going to equal that 1. We write about this 1 has to equal half of my x that I'm going to use here. Multiply by 2, multiply by 2, we get 2 has to be this x. I have to use 2 to get an answer. So the new graph, remember, the x's are changing, but they're not half as big as the old one, are they? What's the relationship between this 1 and that 2? Is it half as big? No. What is it? It's twice as big. It's twice as big. Plug in 2, half of 2 is 1, and f of 1 is 0. I get that for 2, 0. I want 3. I need this to actually be y equals 1/2 f of 1/2 of something, which is going to give me f of 3. Half of what number is 3? 6. I want 3 equals 1/2 of some number x. I want half of 6 multiplied by 2. Multiplied by 2. 6 equals this x. I have to plug in 6 in order to get the whole 3. So again, think about the premise. In order to make 1 happen, this had to be twice as big because I'm going to take half of it. In order to make 3 happen, this had to be twice as big because I'm going to take half of it before I actually plug it in. Half of 6 is 3, half of 3, 1. So the X that I'm about to pick next, I'm gonna take half of it and I want half of it to be 4. Half of what number is 4? 8. In order to make this 4 work out of here, I have to start with an 8. Because I'm gonna do f of 1/2 of this X coordinate. And I'm gonna plug it in, half of 4, and then we'll get half of 8 is 4, half of 4 is that 2. That's the only way I'm gonna get to 2 half. So when there's a half in front of your X, you have to double the X's as your new X coordinate. All the X's get doubled. If it was a third of X, you would triple all the X's. If it was 1/4 of X, you'd have to multiply all your X's by 4 if you think you put them in.
Okay, it sounds silly, but it just doesn't seem fair to the other side. Would you have to switch the two, like that one would automatically, the second column down are 1 and 0, and the pair is 2 and 0. That, yeah. So that wouldn't automatically turn that other point right there into a 2, so it would just be 2, 0 on the other side.
On the other side,
I know.
So
On it's why, right on the left side.
over here,
No. Oh, wait, you're my right there. Yeah, that wouldn't just, you wouldn't just,
no, so this is the original graph.
Yeah.
Okay,
just doesn't see pair the 1. Like I'm
so what,
change
so,
that to a 2 and just leave it as a 2 then.
no, so I need to know, what is my new graph gonna need? What X do I need to use in my new graph to make this viable? So since I'm gonna take half of X before I can plug it into the function, to use these values, this X has to be a 2 for my new picture.
Oh, okay.
So I'm gonna take half of X before I can plug it in. I only know what happens when I can plug in 1. So to get a 1, I have to start with a 2. To get a 3, I have to let X be a 6. To half of 6, then I have a 3. To get a 4, I have to use X as an 8 because half of 8 gives me that 4. So these are the X's. The X's have to be twice as big because before I plug them into the function, I'm going to take half of the number.
Okay.
So they have to be twice as big. And so the graph will look like this. It's going to be stretched. We did, and I think it was E. It was Y equal, it might have been 2 times f of X, where the 2 was on the outside of the function, and all the Y values were twice as tall as the original, so it stretched it vertically. This is 1/2 in front of the X, and it's stretching it horizontally. Everything is stretched that way. But again, I'm not going to have you do something like that test-wise. Focus on A through E.
My left hand, sorry.
I'm going to turn off the recording.